For day 5, we're talking about a perpendicular bisector, which is an extension of the perpendicular idea. We talked yesterday about lines being perpendicular, and we talked about how that means that the two lines will intersect to form a right angle. Today, we're referring to a perpendicular bisector of a line segment. So in the picture that you see here, we have a line segment that goes from E to F, and we also have a ray that starts at M and goes through point N and keeps going. And our directions in this question are saying that MN, this ray, is the perpendicular bisector of the segment that goes from E to F. What that means is we know two things. One of the things that we know is that where they intersect at point M, there will be right angles formed. So in this case, we have two right angles formed. The other part that we know is that the two segments that segment EF is split into will be congruent to each other. So in other words, the part that goes from E to M and the part that goes from F to M will be congruent to each other. So if I'm going to write that information down, I can say that because I have a perpendicular bisector, I know that angle 1 and angle 2 are right angles. And then I also know that the segment that goes from E to M is congruent to the segment that goes from M to F. So perpendicular bisector does one more thing. Other than meeting at perpendiculars, it creates a midpoint, and therefore we have two congruent segments. There is a rule that says that every point that sits on the perpendicular bisector is equidistant from the endpoints. So I want to take a minute and talk about that rule. THM stands for theorem. That really means a rule. And I want to talk about how if you take a look at any point that sits on this perpendicular bisector, so consider any point that you may see along there, if you were to go back and measure how far that point is away from endpoint E and how far that point is away from endpoint F, you would find out that they're the same. I could do the same thing with this point. If I measure from E to that point, and then I measure from F to that point, those measurements are the same. And we can continue on. I could do it with this point, and I could measure from E to that point and then F to that point. So any point that sits on this perpendicular bisector right here will be equidistant from the endpoints. So question number 1 talks about how AB, line AB, is the perpendicular bisector of segment CD. So I'm going to draw a picture for that. So what I have in my picture is I have a segment that goes from C to D, and then I have a line AB that is going to hit CD at a perpendicular and be the bisector of it. So the bisector of it means that we have a midpoint. So here is my midpoint. And in this particular case, I'm going to have, actually I should label that E. I just realized they told us that that point was E. And I have a line that goes from A to B, passing through A and B at point E. And they tell me in this particular question, once I have the picture drawn, that CE is 8x minus 5, and that ED is 2x plus 19. And because I know that I have a perpendicular bisector right here, what I also know is that these two smaller sections have to be equal to each other. So in this particular case, I'm going to say that 8x minus 5 has to be equal to 2x plus 19, the length of those two segments. So when I go through and do this math and solve, I get that x is 4. Again, I'm not really focusing too much on that algebra. My concern is that you know how to set this equation up. The second part of this question talks about angle BED, and they're saying that angle BED is equal to 3y plus 12. So if I look at where angle BED is, that's this angle right here, and because the lines are perpendicular, I know that angle is equal to 90 degrees, it forms a right angle. So if they tell me that that angle is 3y plus 12, and I know that the angle is also equal to 90 degrees, then I know that 3y plus 12 has to be equal to 90. And then I'm going to go through and solve. And when I divide, I get 26. So 26 is my y value. The next thing that you see on this page are directions. I shouldn't say directions, steps for you to go through and do a construction of a perpendicular bisector. If we did not do this together in class, you are going to look on widths and fill this in. On widths, under the links tab, you will find a video for how to construct the perpendicular bisector. So if you need to pause the video now and go to that, feel free, or you can wait till the end of this lesson and go in and look that up. When you flip to the next page, we're going to talk about writing equations of perpendicular bisectors. So when we write the equation of a perpendicular bisector, we're essentially writing the equation of a line, which means we should be using y equals mx plus b. In question number 3, it tells us that we're going to find the perpendicular bisector algebraically. So what I'm going to do is I am going to plot the 2 points that they give me to create the segment. So one of my points is right here. It's point A, negative 4, 0. And then the other one is 2, 4, 6, 8, 1, 2, 3, 4, 5, 6. So here's where this other point is. And that's going to be point B. And then I want to draw a segment to connect those two. So I'm going to go ahead and draw a segment to connect those two. So here is my segment connecting points A and B. I am in charge of finding the equation of the perpendicular bisector of that segment. By definition, my perpendicular bisector must do 2 things. It must be perpendicular to the segment that goes from A to B, and it has to bisect it. So if it bisects it, what that means is that it hits at the midpoint. So one of my jobs is going to be to find the midpoint, and because I'm doing this graphically, it means I can look at my picture and kind of eyeball where I think that midpoint is. And I think that the midpoint is going to be this point right here. So I'm kind of eyeballing it, and I'm going to eyeball that and find that my midpoint is at the point 2, 3. So if I'm thinking about this, and don't write this down because I'm going to erase it, what I'm noticing is I have to basically write the equation of this line, the line that looks like it bisects and is perpendicular to that. So I'm going to take that out of there. Now the other thing is that not only do I have to find the line that bisects this segment, I also have to find the line, equation of the line that's perpendicular to AB. So I'm going to use the idea of slope. If I look at the slope of AB and I'm looking at the graph and I count, I can find out that the slope for this is going to be up 1, actually up 2 over 3. 1, 2, 3, 4, 5, 6. Up 1 over 2, actually I think it's up 1 over 2, up 1 over 2, up 1 over 2. It's a little hard to see. My line's a little off, I think. Yeah, so I counted the whole slope. I said if I do this, I think my line's a little off, so it's hard for me to do this. But if I count slope like we've done before, I'm going up 6 and over 12, which should be a slope of 1/2. I know it's a little hard to see in mine because my line is a little off, but that's really what the slope is. So I basically, now that I know that my line that's perpendicular to this has to have a slope of up 1 over 2's negative reciprocal, that means that my slope of my perpendicular bisector has to be the negative reciprocal of that, which is going to be negative 2 over 1. So from the only point I know that the perpendicular bisector passes through, I have to count a slope of down 2 over 1, down 2 over 1, down 2 over 1, and then we go off the page. So we want to kind of go back in the other direction now. And that's where my line is going to go, that is my perpendicular bisector. So when I do this, I'll get a line here. Maybe it'll let me move it a little. No, maybe not. So in this case, here's my line. And I have to write the equation of this line. Remember, when we write the equation of a line, we have to know its slope, which we have is negative 2. I also have to, from the graph, find its y-intercept, and I can count that. The point is right here, 1, 2, 3, 4, 5, 6, 7. So my y-intercept is 7. So that means that the equation of this perpendicular bisector is y equals negative 2x plus 7. So there's the y-axis, there's the x-axis. Don't forget to label those. That's my final answer, the equation of that line. That's the perpendicular bisector. When you go on to the next two questions, they're telling you that they want you to change how you are doing this, and you will see that they want you to algebraically find the equation of the perpendicular bisector. That means that we do not pull our information off the graph. We actually have to do some math, and our graph is just there to help us. So we're expecting a lot more work for this question than we had from the previous question. So when I plot the points, negative 4, 6, here's point C, and point D, which is 8, negative 2, here's where D is. I basically am going to have a segment that connects the two of them. So from point C to point D, there's my line that connects the two of them, my line segment. And when it says that I have to find the equation of the perpendicular bisector, when it talks about an equation, we know that with an equation, that means we're going to be using y equals mx plus b. And with y equals mx plus b, our job, as we've talked about a couple of times in this unit, is to find the slope. Now, what we're finding the slope of is the line that's perpendicular to CD. The way that I find that is I find the actual slope of CD, and you can use m or you can write the word. And in this case, we're going to do it algebraically. We know slope formula is y2 minus y1 over x2 minus x1. So I'm going to find the slope of CD. And I'm going to use the points that I have here. So this is going to be negative 2 minus 6 over 8 minus negative 4, which becomes plus 4. So this is negative 8 over 12, or negative 2/3 when you reduce. So that is the slope of CD. Our new line that's the perpendicular bisector has to be the negative reciprocal of that. So we're going to say the slope of the perpendicular bisector is positive 3 over 2. We also have to use our algebra to find the coordinates of the midpoint, because we need to know exactly where our perpendicular bisector is going to be drawn. We know from this how it's going to be tilted or what its slope is, but we need to know a point it passes through, and a perpendicular bisector always passes through a midpoint. To calculate a midpoint, what we're going to do is we're going to take our x values and divide by 2, and then we're going to take our y values and divide by 2. So when I do the midpoint of this segment, it's the middle point. When I do this, to calculate the midpoint, I am going to take the x values and add them and divide by 2. I'm essentially averaging them. So negative 4 plus 8 divided by 2, and 6 plus negative 2 divided by 2. When I calculate, negative 4 plus 8 is 4 divided by 2 is 2. And then here, 6 plus negative 2 is 4. 4 divided by 2 is 2. It tells me that my midpoint is right here at 2, 2. And then I'm running out of a little bit of room writing on the smartboard, so I'm going to keep going to finish this question right into question 5, and then I'll come back and erase it to do question 5. So once I know a point that the line passes through, that's a legal x value and a legal y value, and I know the slope, now I can find b. So I can find the y-intercept. So when I find the y-intercept, I use y equals mx plus b. I plug in the 2 for y, the 3 over 2 for m, the 2 for x. So I get 2 equals 3 plus b, or b equals negative 1. So my line that's the perpendicular bisector, I right now know has a slope of 3 over 2, has a b value of negative 1, which means I can write the equation of that perpendicular bisector. Here's negative 1. If I go up 3 over 2, up 3 over 2, etc., I can see where that line is going to go. So from this point to this point is where my perpendicular bisector is going to go. That is the perpendicular bisector, and this is the equation. This is the equation that is going to be for that perpendicular bisector right here. A little bit of work if we have to do it algebraically. It takes us a while. We have to calculate the slope of the original line, talk about the slope of the perpendicular line, find the midpoint because it's the only point we will know that that perpendicular bisector passes through, and then go through after that and find the b value. That's a lot of math if you're asked to do it algebraically. So what I'm going to do in my next step is I'm going to go back now and erase all of this, and then I'm going to go on and do question 5. It would be good if you could practice question 5 on your own without having to watch exactly what I'm doing, and maybe check your work against mine. Okay, so question 5, same thing that we did in the previous question. When I look at this, I realize that they are telling me that they want me to solve this algebraically. That means I have to show work for all the math I do. I'm using my graph as a guide to make sure that what I'm doing makes sense. One of the points that I'm plotting is point E. The other point that I'm plotting is point F. And I am essentially looking for the perpendicular bisector of this segment. That means that there's two things about this segment. One, that the segment will be perpendicular to EF. The other thing, that it's going to bisect EF, which means it's going to hit at the midpoint. So step number 1, I am going to find the slope of EF, and I'm doing it algebraically. I know I could count this from the graph, but I'm going to use y2 minus y1 over x2 minus x1 because it says algebraically. So this is 0 minus 3 over 4 minus negative 3. So in this case, my slope is negative 3/7. That means that the slope of the perpendicular bisector, which is what I'm really looking to find, has to be the negative reciprocal. So I'll put negative reciprocal is going to be 7 over 3. The other thing that I need to find is I need to find the actual midpoint of EF, because it's going to be the only point that I know that this line passes through. To do midpoint, we use the midpoint formula. You could do this in your head if you wanted to, but sometimes it's nice to be able to use the formula and get it exact. So when I do the midpoint formula, which is add the x's, divide by 2, add the y's, divide by 2, I am adding x's of negative 3 plus 4 and 3 plus 0 divided by 2. When I do this math, I have negative 3 plus 4, which is 1 divided by 2. And then I have 3 plus 0 divided by 2, which is 3 halves. You may, because we're graphing this, want to convert those to the nice decimals that they are. So 0.5, 1.5 means our midpoint is going to be about here. So this point is our midpoint on our segment. Please do not forget what we are looking for. We are looking for the line that is perpendicular to EF, segment EF, passing through the midpoint because it bisects it. So when I get to this point, I am now at the point where I say, okay, I have information that I need to continue on to part 3. I know a point that the perpendicular bisector passes through, which is point M, 0.5, 1.5. And I know the slope of the perpendicular bisector, which is 7/3. I have to find the B value. When I find B, the y equals mx plus b, I substitute into this everything I know, and then I'm going to solve for B. So this is 1.5 equals 7/3 times 0.5 plus b. So this is 1.5 equals 3.5, I'm sorry, 3.5 divided by 3 plus b. And then I'm going to go through, use my calculator, and get that value. So on my calculator, when I put that into my calculator, I get 0.3 repeating, which is 1/3. So my y-intercept is 1/3. So now I go back to what I know. I know my y-intercept, I know my slope. So my part 4 to this question, so now we're moving on to part 4, is to actually write the equation of the line in y equals mx plus b form. My slope, 7/3, my y-intercept, 1/3. So y equals 7/3 x plus 1/3. My y-intercept is about 1/3. I connect those two to make my perpendicular bisector. The equation of that perpendicular bisector, y equals 7/3 x plus 1/3. Not very nice numbers. If you have your calculator, though, you should be able to work your way through that.